Welcome to the last video of the transformations unit, and we're going to cover inverse relations today. So the inverse graph of f of x is a reflection over y equals x. So instead of reflecting over the x or y axis, we are reflecting over y equals x. And this is the mapping for our transformation. So your original point xy now becomes yx. So your x value now becomes the y value of your new graph, and your y value now becomes your x value. Here's an example of the inverse relation between y equals x squared and y equals plus or minus the root of x. So the blue here is our y equals x squared. This dotted red one is your inverse. So in our first example, we are going to find the inverse of the following graph. We're going to use the mapping that was given to us as a rule, that xy becomes yx. Now we're going to pick a few points from the graph that was given to us, and then we'll perform that transformation. So I'm going to use those 3 points, 2, 1, 1, 0, and 0, negative 4. We can also maybe just use one more. Here, that's 4, 2. Now our new graph, we're just going to switch the x and y points or coordinates. So 2, 1 becomes 1, 2. 1, 0 becomes 0, 1. 0, negative 4 becomes negative 4, 0. And lastly, 4, 2 becomes 2, 4. So I'm going to go ahead and graph our new set of points. And then I'm going to connect my points from left to right. Looks something like that. So that is your inverse graph. And if we think about what we are reflecting upon, we're reflecting upon the y equals x. So if I want to draw in our line of reflection, this is our mirror line that we're reflecting upon. In the next example, we're going to find the inverse equation algebraically. So there are a few steps that we have to follow. The first step is to let f of x be the function that we're trying to find the inverse of, so x squared plus 3. Second thing we're going to do is we're going to rearrange this equation here. And we're going to switch our x and y value. So instead of y equals x squared plus 3, I'm going to have x is equal to y squared plus 3. Now we're going to rearrange and solve for y. So that means I'm going to move the 3 to the other side and then square root both sides by y. And when I do that, I'm going to get a plus minus in the front. So our answer is the root of x minus 3 plus or minus, and this is our inverse equation. Step 4 is to put it together. So that means we found f inverse of x. Remember, we let x squared plus 3 be f of x. And this is what we just found, which is plus or minus the root of x minus 3. And that's our final answer. Now we're going to sketch our parabola of x squared plus 3, the original graph, and also the inverse. So we have a vertex at 0, 3. It's going to spin like this. That's our parabola. And then we want to graph the inverse of that, which is plus or minus the root of x minus 3. So that means we're going to start off at 3, 0. And we are not stretching or compressing this, so our next point is going to be 1 up, 1 over, something like this. And because it's plus or minus, we're going to have another arm on the other side. And that would be our inverse graph. And if you want to, you can see that this is the inverse graph by drawing in our line y equals x to show that that was the reflection line. You don't need to draw that in, I'm just showing you that that's our reflection line and how that relates to each other. Those two graphs relate to each other. So is this f inverse graph, or plus or minus root of x minus 3, a function? This would be a no, and that's because it fails a vertical line test. And that is if I put my pencil up and down along here. There are 2 points for every x value. So if that occurs, you know that you don't have a function. Now I want you to try A and B on your own. I want you to find the inverse graph of that blue graph using those points. So using points and the rules of your mapping. And then I want you to find the inverse of the function that's given to you in B. And when you're ready, press play for the solution. Okay, for try it yourself A, I'm just going to write down the points that we have, which is -4, 0, -2, 4, 0, 0, 2, -4, and 4, 0. Our transformation is switching our x and y values. So this becomes 0, -4, 4, -2, 0, 0, -4, 2, and 0, 4. And I'm going to plot those points in here. I'm going to make sure that I'm connecting these points in order. So I'm going to go from the 0, -4 to the 4, -2. Then I'm going to go to 0, 0, -4, 2, and lastly 0, 4. So this is our inverse graph. Now we want to find the inverse of y equals 2x plus 1 over 3. The first step is to let f of x be this, so that we can name that this is the inverse at the end. Then we're going to switch our x and y. So x is going to be 2y plus 1 over 3. Now we'll rearrange this and solve for y. I'm going to multiply by 3 on both sides. Move the 1 to the other side. And divide both sides by 2. This is my inverse graph. So I'm just going to put it all together. f inverse of x is then 3x minus 1 over 2. And that's our final answer. In example 3, we're going to determine two ways to restrict the domain of y equals negative x squared plus 5 so that the inverse is the function. Well, let's find the function first, this inverse function. So I'm just going to switch my x and y and then solve for y. Multiplying both sides by a negative 1, we're going to get 5 minus x, and then I'll square root both sides. This will give us a plus or minus the root of 5 minus x. So this is what we have. And I'm just going to graph it so we can visually see what this inverse function is. So we have a point, which is like our vertex, at 5, 0. And then if we look for our next point and do a table of values, we're going to have a point at 4, 1 and 4, negative 1. Because if I plugged a 4 in here, you're going to get plus or minus the root of 5 minus 4, which is just going to be plus or minus 1. You can do it for another point if you want as well, but really we just need an idea of what this looks like. So it looks like this right now. And we can tell this is not a function because it doesn't pass the vertical line test. So to be a function, we can only need to focus on one piece at a time. If I only had this portion of the graph, that is certainly a function. Or if I had just the bottom part of the graph, this is certainly just a function as well. So what we're going to do is we're going to restrict our range of our inverse function, which would then restrict the domain of the original function. So to be a function, we're going to take the top portion, which is the yellow portion that I highlighted. This is going to be y equals the root of 5 minus x, not the negative one, but the positive one. And this would have a range of y is greater or equal to 0, because our y values are all positive. So this means if I refer back to my original function, we need to restrict the domain of our original function to just x is greater than 0. Remember that your relationship here, so when you take the inverse of your original graph, your inverse graph is going to switch your x and y values. So your domain in the original graph becomes your range in your inverse graph. Okay, so that was one part. And our next part is the bottom portion, which is below the x-axis. And that equation is negative root of 5 minus x. And this range is going to be y smaller or equal to 0. So then if I want to refer back to my original function, we're going to have to restrict its domain. Then, so that x is smaller or equal to 0. Remember, it's the same sort of thing as the one from above, where my original functions domain becomes my inverse functions range because your x and y values switch. Our last example. I want to determine algebraically whether the functions in each pair are inverses of each other. So I'm going to take this one and then find its inverse then. So I'm going to switch the x and y values and then rearrange to solve for y. So I'm going to add 3 to both sides and then divide by 7 on both sides. And if you take a look, sorry, that's supposed to be y here. If we take a look at these two, they are the same. Let's do one more here. So I'm going to take this one and find its inverse. I'll switch the x and y value and then rearrange and solve for y. And subtract 1 on both sides. Square root both sides. And then add 2 on both sides. And then we need to compare between these two. Are these the same? They're not. This is a plus or minus the root of x minus 1. This is just the plus version. So it's not the same. And that's because we don't have that negative root of x minus 1 plus 2. This is part of your inverse. But it's not equivalent to y equals the root of x minus 1 plus 2.